Hi, AB Calculus class. This is 2019 question number 6, and I call the topic Random Craziness. You might see stuff like this on your AP exam this year. It's just a lot of information everywhere, and the great thing about this question is there's at least an important piece of information to reach out and grab that I need you to understand. So, let's go ahead and start with this first thing, okay? They give us the ordered pair g of 2 and h of 2 equals 4. You literally don't even use that until part C, just seems out there, and then part D a little bit. You're given this. Now they say this is the tangent line to g of x at x equals 2 and h of x at x equals 2. And this is one of the most important things to the whole question. The fact that this is the tangent line to both of these equations. Now, it's going to help us from the very beginning, finding out part A. So part A says, what is h prime 2? And folks, you need to know h prime 2, because if you don't know h prime 2, then you can't use h prime 2 in part B when you need it later on. So they're trying to help you to do part B with part A. Part A is like, hey, get this information. But here's the thing. Let's say you have no idea what h prime 2 is. You don't know at all. You're going to need it later on in part B. You can make something up. So if you had no idea, you could say, I don't know. But for the purposes of later portions, let h prime 2 equals, and then you just make up anything. I just said 7. It's wrong, but later on when you get to h prime 2 and you need to plug something in, you plug in 7. As long as you take your answer from part A and plug it in the right place in part B, you'll get all the points for part B. So this would be worth no points, but it can help you get points later on. So, one important thing is if you have absolutely no clue how to find something, you can always just quickly say that. I don't know what it is, but for the purposes of later parts, let's just let this equal this. And then if you need it on the next portion, you just use this one, even though it's wrong. You can earn still all the points. So, obviously not the right answer. The right answer is incredibly easy because you have to think, what does this mean? h prime 2 means the slope of the tangent line, specifically at x equals 2. So h prime 2 is the slope of the tangent line of h of x, slope of the tangent line of h of x at x equals 2. Well, what is this? This is the tangent line to g of x and h of x at x equals 2. So we need the slope of the tangent line at x equals 2, and this right here is the tangent line. So folks, if this is a line, what's the slope? Now all they did is they took point slope form, y minus y1 equals m times x minus x1, and all they did was they got y by itself in this problem by taking this piece and adding it to the other side. So they added the y1 to the other side, and they put it in front. The reason I'm pointing this out is that right there is my slope. If you were to distribute and get it in y equals mx plus b form, this is the slope. So this right here, not only is it h prime 2, because it's the slope, this is the slope of the tangent line, but this right here is also, if we need it later on, I don't know if we do or not, it's also g prime 2, because it's the slope of the tangent line of g. And this is key. So, h prime 2 is what's the slope of the tangent line of h of x? Well, this is the tangent line, and that's the slope of the tangent line. So the answer is 2/3. Okay. So that's part A. I'm going to leave part A up here because for part B, we're going to use it. Okay. So part B, they say let a of x equals 3x to the third h of x, and they want to know what is a of a prime x. So they want to know what is a prime x, and ladies and gentlemen, you've been in calculus the whole year. If you don't do this part right, you don't deserve to pass. If you make a mistake today, this is the chance to learn from your mistake. And on the test, you have to look out for when you're taking the derivative, they want to see, do you know the product rule or the quotient rule? This is the product rule. Remember, it's 1 d2 plus 2 d1. So 1, it's the first piece, times the derivative of the second piece. This is the second piece, so the derivative of h of x is h prime x. Plus the second piece, h of x, times the derivative of the first piece. The derivative of 3x squared is, 3x to the third, the 3 goes to the front, that's 9x squared. So that's the first part of the question, and the second says evaluate it at 2. So we plug a 2 in for everything. Ooh. Now, I know we live in America, and it's a great country, and we want to be able to leave our answers without finishing them. You cannot leave it here for two things. You can't leave this, and you can't leave this. Everything else is fine. Those are not fine. So our answer, let's start here. What is h prime 2? Well, that's the whole reason they asked us to find that before. H prime 2 is 2/3. And if you didn't know h prime 2, remember when I made up, let h prime 2 equals 7. You just put a 7 there. All right, and now we need h of 2. Well, h of 2 is up here. That's one of the random pieces of information. H of 2 equals 4. Sorry, I didn't think we were going to need that until later. And there. That's where you can leave it. Okay? So, when you want to leave it, when you want to say, hey, earn it, I don't feel like grading it, or this is America, I'm leaving my answers this way, you can't leave things like this. You can't leave things like this. Even things like this, cosine of pi over 3. You can't leave that. You'd have to use a quadrant angle or the triangle. This is the pi over 6, pi over 3 triangle. These are things you can't leave. Anything else you can leave. All right, that's it for part B. And now part C. Part C says that basically h of x equals blah, 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 blah. It is known that the limit can be evaluated by using L'Hopital's rule. So let me quickly make sure you understand L'Hopital's rule and what you need to write to get all the points. Because some of you did not do a good job on your quiz of writing all the perfect things which are important. So, if the limit as x approaches a of f of x over g of x, x approaches a, x approaches anything. Anyways, if you either get 0 over 0 or infinity over infinity, it can be either one of these, 0 over 0 or infinity over infinity, then by L'Hopital's, we'll just say by, oh my gosh, I can't spell, by L'Hopital's, the limit as x approaches a will be f prime x over g prime x. So again, you first have to show you get 0 over 0 or infinity over infinity. And you have to show it. If you don't write 0 over 0 or infinity over infinity, and you just say, I'm using L'Hopital's, you get no points. You can't use L'Hopital's unless you get 0 over 0 or infinity over infinity. Then you need to say, I'm using L'Hopital's. And then L'Hopital's is not taking the derivative using quotient rule. It's not low d high minus high d low over low low. It's the only time you avoid quotient rule with a fraction. You just take the derivative of the top and the bottom separate. Okay? And very, very important, one last thing. When you do L'Hopital's, you have to recopy this part down. Otherwise, they can refuse to give you points. 2 years ago, L'Hopital's question was worth 3 points. If you didn't write this part down, and you did everything right, but you didn't copy this part down after doing L'Hopital's, they only let you earn 1 out of the 3 points. Brutal. When you do L'Hopital's, you need this, one of those, this, say you're using L'Hopital's, and then this. And when you take the derivative of the top and bottom, you got to recopy the limit part down. Okay, so why is this important? They're saying that the limit I go, oh, this is part C. Let's just get rid of this. I don't think we need this anymore. If we need it, we can remember that. So part C says we're going to use the limit as x approaches 2 of h of x. Now here they already told me what h of x is. So they said h of x is x squared minus 4 over 1 minus f of x to the third power. And by the way, this question is worth a ton of points here. So they want us to do the limit as x approaches 2 of this to get our answer using L'Hopital's. Now, first of all, they want us to find out what is basically the limit as x approaches 2 of h of x. So just really quickly, if I want to know what's the limit as x approaches 2 of h of x, and I am plugging in a 2, they want me to be able to find out what is h of 2. The limit as x approaches 2 means if I plug a 2 in here, I'm finding h of 2. And do we know what h of 2 is? If you don't get this part, you're not going to be able to get all of it. Do I know what h of 2 equals? Look at the very beginning. What did they tell you? H of 2 equals 4. So when I go ahead and do all this, I should get an answer of 4. Okay? And that's going to be key, knowing the whole time that this will equal 4. All right. Well, they say that we are going to get our answer by using L'Hopital's. Does that mean that I can just go ahead and take the derivative of the top and bottom right now? No. First, let's look at what we're trying to find. We're trying to find two things. What is f of 2? And what is f prime 2? Well, guess what? If we want to find f of 2, so we're not going to go any further right now. If we want to find f of 2 is right here. This is f of x. So to find f of 2, I actually need this equation. So the very first part is, how am I going to use this? I'm not doing L'Hopital's yet. How am I going to use this to find f of 2? And this is how. When can I use L'Hopital's? If I get 0 over 0 or infinity over infinity. Well, let's go ahead and try our limit question. So I'm going to keep this part out here, and I'm going to say, all right, well, the limit as x approaches 2, and I'm going to put a 2 here. Now, look at what we get. On the top, we get 0. So notice, it is not going to be infinity over infinity that gives us L'Hopital's. It's going to give us 0 over 0. So, we would say because this is 0, this must equal 0, since we are using L'Hopital's. Since they told me I was using L'Hopital's, again, it's either 0 over 0 or infinity over infinity. Well, if my top is 0, that means my bottom better be 0 in order to use L'Hopital's. So we know if we're going to get 0 over 0, 1 minus f of 2 to the third has to equal 0. And now we just solve. I'm going to subtract the 1 to the other side. Hard question, by the way. I understand this. So I'm going to subtract this 1 to the other side. Then I'm going to get rid of the negative by dividing by a negative. And then I'm going to get rid of the third power by cube rooting. And if I cube root, the cube root of 1 is 1. And we get f of 2 is 1. That's really weird. But that's the first thing I had to find. What is f of 2? 1. Okay. So I've used this right here. And I used this and got the answer of f of 2. I don't need this anymore. Now I need to move on and find f prime 2. Now I can't find f prime 2 if there's not an f prime x. So this is where I'm going to use L'Hopital's. All right. So I erased my work here, but we already have the 0 over 0. So we're going to say by L'Hopital's. And remember, if I'm going to use L'Hopital's, I keep the limit. So the limit stays here. I take the derivative of the top, and I take the derivative of the bottom. Well, the derivative of 1 goes away. And what's the derivative of this? Well, pretend this was a 1 minus x to the third. you would just say the derivative is negative, and then you take the derivative of this. Let's make it a u. The 3 would go to the front for this piece. The exponent would go down by 1 times chain. So the derivative of this piece, this is like a u to the third. The negative stays here. The 3 goes to the front, da-da-da-da-da-da, to the second, and then times chain. The derivative of f of x is f prime x. All right. Now, what am I going to do with this information? Well, a couple things. First, I'm going to plug in a 2. So equals, and I'm going to put a 2 here, and I'm going to put a 2 here. All right. And you might think, well, that's great, but I'm stuck. But I'm not stuck. I did L'Hopital's. I plugged in a 2, and I actually know what the answer is because I knew in the very beginning I could find, when I find my answer using L'Hopital's, I would get 4, the actual value of h of 2. So if all this has to equal 4, let's finish the problem. First of all, here on the top, I'm just going to go in this direction. Okay. Here on the top we have 4. On the bottom we have negative 3. We actually know what f of 2 is. We found that earlier. F of 2 is 1. So 1 squared. And now down here we have f prime 2 equals 4. Now, you could do a lot of fancy math, but here's what I did. I just thought of this as a fraction. I could cross multiply and divide. You can do that. But I just thought if the tops are equal, 4 equals 4, then the bottoms have to be equal. So this has to equal 1. But if you cross multiply and divide, you'll get to the same point in just a bit. Negative 3, this is 1. So I don't have to write that down. All of this is going to equal 1. And then I'm going to divide. And I get f prime 2 equals negative 1/3. And I'm making sure it's right because that's a crazy question and I don't even feel great about it. But it is correct. Okay, and there you go. And then that's part B. Alright, that's all done. That's great. Part D is worth 1 point. It's a horrible question. If you just want to turn off the video now, that I understand. I'm going to show it to you really quickly. It's worth 1 point. Great. Alright, so for part D, it is known that g of x is always less than h of x. And it is known that g of x, and here's k of x, and then h of x, for 1 to 3, is k continuous at x equals 2. So we've never even talked about this before. It's called the squeeze theorem, but just really quickly, let me just show you. If g of x is less than h of x, so here's h of x, we have no clue what it looks like, and here is g of x. Now, basically, k is a function that is always between them. Now, if it's always between them, that means it always exists. But just because k of x is between them and it always exists doesn't mean it's continuous at 2. So let's say this is at 2 right here, okay? So if we had, graph, here's 2. How do we know something like this doesn't happen? Notice k of x could be a piecewise function that always exists. It's between these two, but it's not continuous because it could have a jump. Ordered pairs exist everywhere. Ordered pairs exist. All the ordered pairs are between, but this might not happen. Well, here is how we're going to be able to figure out. It is called the squeeze theorem. Okay? I'm going to give you a riddle. I'm thinking of a number between 4 and 4. What number is it? That's correct. It's 4. So the way the squeeze theorem works is that if you know that k of x is always between these two, and you know what both of them are, let's look at what happens at 2. We actually know what g of 2 is. G of 2 is 4, and we know what h of 2 is. H of 2 is 4, And if k is between those two, that means k of 2 has to equal 4. And remember, the only thing that I said that could have kept k of x from being continuous is if there was some sort of jump. But there can't be a jump here in this problem because these are both approaching 4. So, here's h of x. Let's just make it look like this. Here's g of x. And k of x. Now, k of x can be doing whatever it wants, but because it has to be 2 right here, it's getting squeezed in. There's not any room for it to jump. It has to jump in here and go out the other side. So, basically, because k is between these two, and these two are 4, k of 2 equals 4, so k is continuous at x equals 2. It's worth 1 point, and I've never even talked about the squeeze theorem. You might not get all points, and that's okay. Thank you for watching. Have a good day.